So in this example, what we're asked to do is to simplify this expression. So what we need to do is we see we have an addition here. What are we adding? We're adding all of this plus all of this. With all these brackets here, you kind of want to simplify this. And so what we're going to do is we're going to actually multiply this to get a series of individual terms, okay? And we're going to multiply this out to get another series of individual terms. Then we're going to gather all the like terms at the end. So we need to multiply this. Now, what kind of polynomial is this, guys? How many terms are there in this expression there, in that polynomial? How many? How many terms? 2, right? 2c and -3, okay? Now, what is that called? A binomial, thank you. Remember that? 2, binomial. This is also a binomial, okay? What is this one? One single term. That's a single term. What kind of polynomial is that? What's that called? No one knows? Monomial, yeah. You've seen that in your book. You've seen that in all your questions so far, okay? Monomial, 1 term. Binomial, 2 terms. What's the one with 3 terms called? Trinomial. Okay, good. Those are what you need to know. All right, so how are we going to do this? Multiply this out. Well, binomial times a binomial, we do distribution. Remember the FOIL method? That's for binomial times binomial. So you can do that. But really, that is just distribution. It's the first term times each of these terms in the second one. So we'll do that. What's 2c times c? 2c squared. 2c times 5 is plus 10c. Don't forget your plus or minus in between each multiplication. So now we do -3 times c is -3c, and then -3 times 5 minus 15. So that's the FOIL method, if you recall. First, outside, inside, last. That's just a fancy way of saying we're distributing, right? So that's what we're doing in this lesson. We're distributing across more than just binomials. So what about this one though? All right. So a lot of kids, a lot of students get this one messed up. All right. You do not have to, and you can't, distribute the 3 to this one and to this one. Okay, I'll say that again. You do not distribute the 3 to this binomial and as well to this one. That's not how you do that. You only distribute across, addition and subtraction. You see how that's not addition and subtraction, that's multiplication. So you can't take this 3 and multiply it by all of the other binomials. You can't do that. You just do one at a time. So this 3 is going to multiply by the c minus 3, and we're going to just do that one first. So let's copy that plus down. If we multiply this, that's 3c minus 9. Everyone see that? Now, this 3c minus 9 has to multiply by this other one. So we take the product of these two and multiply it by the third one. So we're going to show another step here. In this second step, we can do some work on this side, can't we? We can gather some like terms, so that's what I encourage you to do. So 2c squared does not have a like term over here yet, or in anywhere yet. But we know that 10c and -3c are like terms, so that's going to be plus 7c when those are gathered. And then minus 15. We'll leave that plus sign there. And now let's do our work of multiplying this out now. So again, 2 binomials, FOIL method if you wish, distribution. Right? That times that times that, this one times that, and this one times that. So first terms are -9c squared. Right? And this is plus 3c. Negative times a negative plus 27c. Negative times a positive minus 9. You'll notice I put this one in brackets because I copied this plus down, but this is a negative term. So I just put those in brackets to separate the plus and the minus. But now we're going to gather all the like terms now. See, now we have all these individual terms, really, and we are going to combine as many as we can that are like terms. So that's way better than having them all bound up in factors. You have to expand, then gather like terms. So does 2c squared have a partner? It does, doesn't it? Now, I've been trying to be fancy here. This is working so well. Do you see how those two are the same? So 2c squared minus 9c squared. Are there any other c squared terms? Nope. What's 2c minus 9c? Negative 7c squared. All right, what other fancy shape can I use here? What about a diamond? Okay. Okay, there's 7c. Where's the other c here? Okay. 7c. And there's another 3c there. And a 27c. Wait, oops. That didn't work so well. Come on. Ish. Okay? So there are common terms there, like terms there. So what's 7 plus 3 plus 27? Plus 37c. Now you simply add up the coefficients. All right. For this final one, let's do circles. So these are constants, right? And copy that and paste it. Let's try that this way. All right, so the constant's negative 15 minus 9. So yeah, please don't say 6. The difference between 15 and 9 is 6. No, it's negative 15. Think about your number line. Here's 0. Here's negative 9, and we're subtracting 15. So we're going further this way. Or you're starting at negative 15 and you're subtracting 9. You're going further this way. So what's it going to be? Negative 24, and they're just constants. All right? Okay, so are we confident with that? That is our answer, yes. Very good. Okay, so that's how you do that type of question there. Let's see. All right, so here's a word problem from your textbook. I'll read through quick as you copy down this diagram. A box with no top is made from a piece of cardboard that measures 20 centimeters by 10. So here you go on your diagram. 20 centimeters is the complete, the overall width of the entire box that, or the piece of cardboard is made from, and 10 centimeters this way. Equal squares are cut from each corner. So you see the white parts here? This is the squares that have been, these are the squares that have been removed from the original piece of cardboard. Okay, and when those are removed, you can see with these dotted lines that the flaps are folded up to create this box right here. Right? So that's sort of what the box looks like. You start off with a piece of cardboard, you cut squares out of there, fold up the flaps, and you got an open top box. All right, everyone see that? That's how they're making this box. Now, the question is, in A, what is the length of the box? What is the length of the box? And I'm talking about this right here, the overall length of this box. So what I'm looking for is this length right here. Okay? Looking for that length right there. Is it 20? Nope, it's not 20. This is 20. So what is this length? How do we get that length from the information that we're given? Anybody have any ideas? Now, I'm not looking for a number like 17 or 16. I'm looking for an expression, because that's all you can get from this. What is the expression? There's a binomial that would express that length. Anybody? Sorry? 10 and 2? Okay. Not quite, no. Anybody else? No? Okay, what are we given? We're given that the original length of the box is 20 centimeters. And I'm also told that some length right here has been cut from each corner. So guess what? That is unknown length x. Okay? Equal squares, and then look right here, this is labeled x. So this is also x right here. And this is x. So if I know that this is 20, and each of these are x, how can I write an expression for the length of the box right here? From there over to there. Okay, you said 20 minus x squared. Okay, let's take a look at that. 20, I like that because that's the entire length. And then you're subtracting, now what are we subtracting? We're subtracting one length of x plus another length of x. So if you write it out like that, that's what we're looking at, 20 minus x minus another x. Does this equal 20 minus x squared? No. Okay, so we'll adjust that a little bit. So what's it going to be? What is this simplified? 20 minus 2x. Do you guys agree with that? Yes? No? No? Yes? No? Okay, what did we just get finished doing? Like terms, guys. Like terms. Are these like terms? Yes, they are. Minus 1, minus 1. So like terms, I can gather those terms. What do I do with the coefficients when I gather like terms? Not multiply them, no. We add them. We add the coefficients. We combine. So negative 1 plus negative 1 is 20 minus 2x. We're just gathering like terms. Look at what we just did. See, with all those fancy shapes, you see that? We have a C term, we have a C term, we have a C term. We just added up the numbers in front, right? So don't get freaked out when all of a sudden we have a word problem. You guys, you're psyching yourselves out here. We have 20 minus x minus another x. That's 20 minus 2x. That's our answer for A. Okay? 20 minus 2x. Now, just out of curiosity, what's the length of the, what's the expression for the width here? Thank you. That was much quicker. 10 minus x minus x. So 10 minus 2x. Okay, that's the width of the box. What is the area of the base of the box? And this is the last one I want to do with you, I think, here. Actually, no, maybe we'll do another one. So this is actually in your question, sorry, this is the C. This is letter number C. So what is the area of the base? The area of the base, okay? We know that this is 20 minus 2x, and this is 10 minus 2x. How do I find the area of this base right here? What do I do to find the area of a rectangle? Length times width, okay? So what's my length? 20 minus 2x maybe? And what's my width? 10 minus 2x. Everyone see that? That's how we're going to find that area, length times width. So do we know how to multiply two binomials? Yep, sure do. So let's go. What's 20 times 10? 200. What's 20 times negative 2x? Negative 40x. And what's this one? Negative 20x. What's negative 2x times negative 2x? Plus 4x squared. Do I have any like terms I can gather here? Yeah. I have an x term and an x term. So if I gather those together, I have 200, and then minus what? 60x plus 4x squared. If you wanted to rewrite that in the descending order of the x, that's great. You can write it like this then. Okay, that's the expression for the area of the base. And just a reminder, when I'm looking at your homework, I need to see your work. Don't put just the answer. I'm seeing that way too often. Which I know the answer is just in the back of the book. Okay? So that doesn't help you or help me know what you're able to do. So show your work. That's what I'm looking for. The process is super important. All right, I will leave this one with you. So D says, what is the volume? So you go ahead and finish that. What is the volume? And I'll show you the answer in a little bit after you've all had a chance to do that. The volume is, we know that volume is length times width times height. In C, we already did length times width. So really, we need to take this area of the base times, and in the diagram, the height is that variable x. Distribute that. We get this for an answer for volume. All right, that's not all the questions from number 16. I did want you to do, I didn't do, let's see. I talked about B, but I didn't write it down. So this is part of your assignment. I'll quickly give your assignment up here, and then you can start working on that.